Okay, we're looking at the 1.1, 1.2 quiz that we took today, August 13th. Okay, so it begins with, and a lot of you took it on the computer, so this is a paper version of that, so I can kind of talk through it here. It begins by asking you to plot a couple of numbers on a number line that I have already given you some fractions in between. Okay, so we can think about this a couple of different ways. If I check spaces here, then this is cut into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections. And because it's cut into 10 equal sections, that means each tick mark is 1/10, right? So I could literally count 23 of these tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and find that 23 tenths falls right here, okay? Or, and this is the method we talked about in class, because the numerator is larger than the denominator, I can take 23 tenths and write it as a mixed number. In order to write 23 as a mixed number, I asked myself, how many times can I take 10 out of 23? Right? So if I take 23 and subtract 10, I'm left with 13. And I can actually subtract it one more time, and I'm left with 3. So I can take 10 out twice, and my remainder is 3 out of 10. Okay, and that's what you're going to see here is we go 1 whole, we go 2 wholes, and then we go 3 of those 10th tick marks. And that's what it means to graph 23 tenths. And we can use that same logic on number 2, which is to plot 17 tenths, right? So I can literally count 17 of these 10th tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that 17 tenths would be here. Or if we use the method where we write 17 tenths as a mixed number, then I would say 10 goes into 17. Okay, well, let's come over here and do a little arithmetic. 17 minus 10 is 7. I can't take 10 out again. So it is 1 with 7 tenths remaining. So I can literally graph a whole and then 1, 2, 3, 4, 5, 6, 7 tenths to get that 17 tenths graphed. Okay? Choose all the classifications that apply to the number -1. Choose all the classifications that apply to the number -1. Now, if we think about the buckets, right, we said, okay, the smallest bucket of numbers includes the natural numbers, which is counting numbers, numbers that I can count on my hands. 1, 2, 3, 4, 5, 6, 7. Well, that does not include -1. So then if I count again, then I would say, okay, I now want to include 0. So I don't want to just talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I want to include 0, not 10, but, counting forever. And so now I'm going to say whole numbers. So these are like, we think about these as the positive whole numbers, the positive non-fraction numbers. Now we're adding 0, right? But we want to remember that if it's in the natural bucket, it fits in the whole number bucket, right? Then I say, okay, I want to add some more numbers. Now I want to talk about 0. I want to talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now I'm including all my negatives, and we call those integers. And I can take this bucket and fit it inside this bucket. And so my integers include all the negative whole numbers, all the positive whole numbers, and 0. And I know I'm using whole numbers loosely, and I shouldn't be, but this would be like -3, 3, 0, 5, -5, 16, -16, right? All that will be included in the integer bucket. And I'm going to run out of room here, but my next bucket is the rational bucket. And now I'm taking all the integers and throwing them in the rational bucket, and the other thing that's going in the bucket is all of the fractions. All the fractions go in here, okay? Now, at this level right here, we're adding. We're saying, okay, there are some decimals that don't fit here, that I can't write as a fraction. And any decimals that I can't write as a fraction, like square roots of non-perfect squares, I want to call those irrational numbers. And guys, these two things are very different. You can't be both rational and irrational at the same time because we're differentiating our decimals, right? Decimals that can be written as a fraction, decimals that can't be written as a fraction. That's the difference. But then all these two numbers come together and they create the biggest bucket of them all, and that is our real number system. Okay? So all the numbers end up getting dumped into the real number system. So choose all of the classifications that apply to -1. I can do that. -1 is definitely an integer. Check. And if it's an integer fits in the rational bucket, so it's irrational. Check. And if it's a rational number, it has to go in the real number bucket. Check. So these are the three that I would mark as correct for my number systems, my classifications, excuse me. Okay. All right. The next one is probably the hardest one on the quiz. Let me back up so you can see this. It says plot a point on the number line where the value represented on the circle graph would be represented on the number line. Okay, so here's the problem. There are 5 segments. 4 of them are shaded. So this represents 4/5. This is in tenths. So I need to figure out, how do I get 4/5 to something out of 10? Well, you learned early on in school, I can multiply the top and bottom by a fraction, and that's going to give me 8/10, right? But if you couldn't remember how to do that, you could take this to 10 segments by splitting each one of these segments in half, right? So now there are 10 total segments, and 8 of them are shaded. So that's another way to think about it. Excuse me. I just need to count 1, 2, 3, 4, 5, 6, 7, 8 tenths, and that is equivalent to 4/5. Excuse me. I'm so sorry. Okay. Next, we're looking at an always, sometimes never statement. And I told you one of these is always true, one of these is sometimes true, and one of these is never going to be true. Okay? So our first one says, integers are irrational numbers. Well, if you think about the bucket system, right, if I think about how the bucket system works, integers are never going to dump into irrational numbers, which makes sense because if an irrational number can't be written as a fraction, it definitely can't be a whole number, right? So this one is never going to be true. All right, next one says integers are also rational numbers. So integers are also rational numbers. So remember, rational numbers are any numbers that can be written as a fraction. So I can take any one of these numbers, and remember this is like -2, -1, 0, 1, 2. It's all these numbers, positive and negative. I can write them all over 1 and make them rational numbers, right? Also think about it like the entire integer bucket fits inside the rational bucket, which is going to make this always true. Always true. One more, integers are also natural numbers. Integers are also natural numbers. So if I think about this, integers are also natural numbers. Well, natural numbers are always integers, but there are integers that are not natural numbers, like -1 or 0, right? It happens sometimes if I'm positive 1, 2, 3, 4, 5, 6, 7, that's an integer and at the same time a natural number. But it doesn't always happen. So that's why this one is sometimes. Okay? Moving on. I said use the number line to help you put the numbers in order. 5, negative 2.3, negative square root of 25, 5/3, and 2.5. Okay? So if I think about this like, okay, here's a whole number, the number 5. Here's 5. And then negative 2.3 is going to be, remember that's the same thing as negative 2 3/10. So that's like negative 1, 2, and then just not quite half. So this right here would be negative 2.3. Negative square root of 25 is equivalent to negative 5. So negative square root of 25 is here. 5/3 as a mixed number. Well, 3 goes into 5 one time with 2 left over. So that would be 1 2/3. So that would be 1 and then 2/3 right here. That's my 5/3. And then 2.5 is equivalent to saying 2 1/2. I think we all know that. 1, 2 1/2. So here's my 2.5. And so then it's very easy to see that I can list them from least to greatest. So that would be negative square root of 25 first, and then negative 2.3, and then 5/3, and then 2.5, and then 5. So use the number line. I didn't see just a ton of people utilizing the concept of a number line to answer this question. It really does make it a lot easier. Number 7 says match each number to its most descriptive classification. So I'll start with the one that I think everybody got right. 0 is a whole number. It's the only number that classifies as a whole number when you're giving it its most descriptive classification. Okay, then this one being negative is your clue that it's going to be the integer. It's going to be the integer. Now I need to sort of like look at these and think about what's going on here, right? So one of them is going to be a natural number, which means a whole number, and 0. No, not 0, just a whole number. Irrational is going to be usually a square root of a number that when I take the square root of it, I get a decimal. And then rational numbers are numbers that I can write as a fraction, right? So if I think about 2.3, 2.3 is not a whole number, so it can't be natural. 2.3 is not a never-ending decimal, non-repeating decimal, so it can't be irrational. But 2.3 can be written as 2 3/10, so we would want to call it rational. Square root of 8, if I type square root of 8 into my calculator, I'm going to get a decimal. And remember, we talked about the square root of a non-perfect square, always irrational. And then a natural number, well, what is the square root of 9 equivalent to? 3. So this one is a natural number. And one more, it says if you were to graph the number 14/5, it would fall between which two integers? And I was excited to see how many people got this right. So easiest way to do this is take 14/5 and write it as a mixed number. Well, 5 goes into 14. We can do a little bit of arithmetic here. I take it away once, I get 9. I take it away again, I get 4. So here's my remainder because I can't subtract 5 again. I subtracted 5 twice and I had 4 left over. So if I were graphing it on the number line, right, I would go to 2 and then I would go 4/5. So I'll go 1, 2, 3, 4 tick marks and I would count it and so that's 1, 2, 3, 4, 5 equal spaces. 1, 2, 3, 4th tick mark. There's my 2 4/5 right there between 2 and 3. All right, guys, I hope this video helped, and I will see you tomorrow.